So all I've joined Amna, Deborah, Faiza, Humam, Tarif, Rajita, Shahid, Fadil. All right. See, in the last class, I had told you some definitions about threshold, wavelength, threshold frequency, threshold potential, and the work function. So basically, all these are the minimum values that is required by a single electron to get ejected from a metallic surface. So there were 4 media through which this could occur. If it is occurring through thermal energy, we call this thermionic emission. If this is occurring through cold cathode rays, we called it field energy. If two moving electrons collide with each other and then transfer of electron occurs, we call it as secondary emission. And if this is occurring through the sunlight rays, then we say sun rays through it, we call it as, or you can say photolight. So we say this is photoelectric emission. So for photoelectric emission also, there is certain minimum wavelength frequency potential required that we call as the threshold one. So photoelectric effects definition we had seen, some graphs we had seen, all are directly proportional. That is, photoelectric current is directly proportional to intensity. Potentials graph we had seen, I told you potentials graph is important. It can separately come when frequency is fixed. Here you make the intensity constant and frequency is different. Then in case of kinetic energy and frequency are directly proportional, but kinetic energy is independent of it. Laws we didn't do. From here we have to do. So do not write down anything in here. I'll let you know wherever you have to write it down because everything is given in the notes itself, which I have provided you. I'll discuss the notes also. So whatever doubts you have, you can let me know. Also now the second class which we'll be having today, the batch in which you all are already there. Amna, Deborah, your second batch. So I already told you, I already informed you all last weekend that we'll be having double classes so that syllabus is completed by tomorrow. So 9 p.m. also you have to join. At 8 p.m. IST, Shahid, Fadil, some of you all have your chemistry JE classes. You will have your class. By the time other students can take a break, 9 p.m. we'll join back. So both the batches timings will be used, but all of you have to join. Not only these students will join, P1, the first batch students also have to join because we have to complete the syllabus and most of your math syllabus is left. So then next week your physics classes won't be there. Your maths classes and all the subjects, whichever extra topics are left, that will be covered by the other subject teachers. I think bio syllabus is fine. Physics is fine, maths is left, so that will be done. So that's why we have to complete the syllabus. So both the days, today and tomorrow, double classes we'll have. First, the way we have it from 6:30 to 8 p.m. IST, then 9 p.m. to 10:30 IST, the way we are having the classes. We'll try to complete major portion of wave optics and by Monday, we'll be able to complete. Okay, now coming to laws of photoelectric effect, just telling you, photoelectric effect is directly proportional to intensity. This graph which we had seen, directly proportional one, that is known as the first law of photoelectric effect. Then the definition of threshold frequency, that this is the minimum value of frequency. Minimum value of frequency that is required for electrons to be ejected from the metallic surface. So this becomes the second law, that there has to be a minimum value. They are directly proportional. That is, number of electrons increases. So you have the threshold frequency, you have the intensity getting increased. Threshold frequency is definition. Then the last one which we had seen, this graph. This is known as the third law. That kinetic energy is directly proportional to frequency and kinetic energy is independent of intensity. However, you keep on increasing the value of intensity, value of kinetic energy will be fixed. So this is it. Last law we have, that photoelectric effect. We are seeing it in detail, that light is striking, a certain criteria is being fulfilled. That is the threshold frequency, threshold wavelength, all these criteria, these are being fulfilled. So once this is done, we are understanding it in a sequential, orderly manner, but it's a continuous process that is occurring. And this is occurring within seconds. And the time that takes it for the light to strike and the the criteria, all the criteria to be fulfilled, and then the electron being ejected, that is the total photoelectric effect emission to occur. It is 10 to the power minus 9 seconds. So it's an instantaneous emission. So this is the fourth law, which we didn't discuss anywhere. So all these laws are nothing else or nothing new that we haven't discussed. At least the first three laws we have already studied it in different areas. Now you just have to combine and write whenever laws of photoelectric effect come. So no need to write it down. These are properly written in the notes. Just pay attention now. Yes, Einstein's theory of photoelectric effect. So basically Einstein mentioned the fact that energy of photons is directly proportional to frequency. This means energy of the photons is directly proportional to frequency. This is it. But now we know that without a constant, we won't be able to solve this, right? So E, how do we remove the proportionality sign in mathematics? We put a equal to sign with a constant. So here the constant that comes is H. This is the energy of a photon. This is the frequency of photon. This is known as Planck's constant. This is known as Planck's constant. So value of Planck's constant is fixed 6.63 into 10 to the power minus 40, minus 30. 6.62 is also written, 6.67 is also written, 6.6 is also written. But the accurate value 6.63 something into 10 to the power minus 34. This is the value of the Planck's constant. And what about the SI unit? Joules seconds. Frequency is seconds inverse. So when the second will go up with the joules, it will be multiplied. So joules seconds. And one more thing. Frequency is one formula is C. Frequency multiplied to wavelength is equal to the speed of light. So if I want to find out what is frequency, frequency will be equal to speed of light by lambda. Frequency is equal to speed of light by lambda. So if we substitute this here, E is equal to hc by lambda. One more thing, class, speed of light, you will be writing it as 3 into 10 to the power 8 meter per second. You know h, wavelength and energy, whatever is asked, this you can write. Okay. Coming to this part, do one thing, write this down. Just write this down because we'll be practicing numericals today. So you will be needing it. Energy, this part. Write it down, then I'll discuss. Okay, now coming to, I hope you have written. Now coming to the work function part and how do we use energy. Basically, the equation that was provided by Einstein. Not only E is equal to h nu we will be using, but we will see some other factors also that will be interfering with it. So work function, I have already told you, it's the amount of energy, minimum amount of energy. So what happens is, there is an incident photon, that is h nu. Now you understand why h nu is mentioned everywhere wherever we are writing. H nu is being mentioned. H nu, that is the energy is falling. This means energy of incident ray is falling. This is a bounded electron. So electron gets ejected, right? But see, one thing, it's not only that this is occurring. When the electron is moving, initially it was bounded. So that bond was strong. So electron wasn't moving. Now when it has started moving, kinetic energy also comes into action. So kinetic energy is present because of the movement of the electron, as well as the energy that is required by the electron, that is the work function is required. So what is the total energy now? Total energy is kinetic energy plus the energy of the work function plus kinetic energy. And this is equal to the total energy. So in energy of the incident photon is equal to the kinetic energy plus the work function. So basically the main equation now that you will be using is E is equal to kinetic energy maximum plus the work function. Okay, kinetic energy maximum plus the work function. Now look what all things we can use here when we are writing. Firstly, E is the energy, kinetic energy is the maximum value, and this is the work function. Now see how can we use this formula. Energy. First, let's talk about energy. Energy can be written as h nu. If frequency is given to you, write it down as h nu. All right. If you have, let's say, lambda, that is the wavelength is given. You do not have information about the frequency. You have information about lambda. So you can modify it as hc by lambda. These are the two possibilities. Whichever variable is mentioned, whichever value is given of the variable, use that to find out this. Now coming to kinetic energy. One formula of kinetic energy is half mv square. Here also v will be v max. Half mv square, right? This you know. One more formula of kinetic energy is there. Charge multiplied to the stopping potential. This means this is the charge, that is 1.6 into 10 to the power minus 19. And this is the stopping potential. So these are the possibilities of kinetic energy that can be used. I am telling you all the forms so that whichever variable is given, whose value is given, you can put it into your equation and you can find out that. Then work function, see, work function will be h nu, but here the frequency will also be threshold frequency because there is a threshold energy, so threshold frequency. Similarly, this will also be written as hc by lambda. Lambda can also be written as lambda naught. Lambda naught means the threshold wavelength. So these are all the possibilities that we can write. So this is what? This is the threshold frequency. This is the threshold wavelength. All right. This is the normal frequency and wavelength of the photon. Now, any construction of the formula, anything. Suppose I have given you one question where you can see frequency is given. So you can now pair any of these. You can pair any of these. From here you can take this. From here you can take this. From here you can take this. From here this, then this. Any combination you can make depending upon it. Like you can write h nu is equal to EV naught plus H nu naught. This is a common formula that we use. Instead of remembering these formula, no, because you have lots of formula otherwise. So it's better if you just remember what I have told you. In that manner, you'll be able to construct it. Suppose I want to find out what is V naught. So from here I can use this. That will be H nu minus H nu naught. From here we can take H common. That becomes nu minus nu naught. So potential will be H nu minus nu naught divided by E, like this. So nothing new. Like this you can use, or properly any combination you can use. Suppose EV naught is equal to, similarly like this you can use HC 1 by lambda minus 1 by lambda naught also you can use. Any combination you can make. Suppose let's say half mv square. Half mv square is equal to, from energy we have H nu minus work function is directly given, let's say, or let's say hc by lambda is given total energy. So it will be work function plus kinetic energy. Let's say kinetic energy is given as half mv square. Work function is given as h nu naught, any combination depending upon the question. So write it down. Not this part. Not this is sufficiently given in the notes properly. Write it from here. Then we'll practice question. Okay, like this question. What is the frequency of a photon whose energy is 66.3 electron volt? So energy is 66.3 electron volt. This is 66.3 into 1.6 into 10 to the power minus 19 joules. This much of energy we'll have. So E is equal to h nu we'll have. So frequency will be equal to E by h. So this is 6.63 into 1.6 into 10 to the power minus 19. And h is 6.63 into 10 to the power minus 11. Like this, you will have the frequency from this equation. All right. One more question. Quickly write it down. One more question we'll discuss. Quickly. Okay, this says that monochromatic light of frequency 6 into 10 to the power 14 hertz. This is produced by a laser. Power emitted is 2 into 10 to the power minus 3. What is the energy of each photon? See, power is equal to 2 into 10 to the power minus 3 watt. Frequency is 6 into 10 to the power 14 hertz. Right? So E is equal to h nu, that is 6.63 into 10 to the power minus 11 into 6 into 10 to the power minus 19. So this will be 40 into 10 to the power 23 joules. Right? So this is energy. Now we have to, what is the energy of each photon? Is equal to h nu. From this we can calculate. This is minus 34. Okay, I'm writing it as 11. 11 was the gravitational constant. No, that's why. How many photons per second emitted? So first part is easy from. For the second part, see, power is equal to number, or directly I'll tell you. Number of photons whenever this is asked. Number of photons is power by energy. So power is 2 into 10 to the power minus 3 by energy is 40 into 10 to the power 3. Right? Energy is 23. So this you can calculate whatever it is. It will be the number of photons. Basically, I wanted to tell you P is equal to N. E is the formula that you have to use in such question where N becomes the number of photons. Write it down. Some graphical portions I have to tell you. Okay, now the graph showing the variation of stopping potential with the frequency. So see, stopping potential and frequency, they are also directly proportional to each other. All right. So the graph is a straight line, but see, we have an intercept. Now to understand this whole graph, no, why is there a space? Why is minus phi naught by e written? Why is the slope h by e? See, we see the equations which we have already done. The kinetic energy is equal to energy minus work function. Kinetic energy is written as EV naught. Energy is written as h nu. Work function is written as phi naught. Now, if I divide the entire equation by E divided by E like this. So from here, what will I be left with? This will be cancelled. So only V naught is equal to. This will be h by E into nu minus phi naught by E. This equation is resembling the equation of a straight line. Y is equal to mx plus c. Y is this? On the y-axis we are having V naught. See, y is the y-axis, that is V naught. So m is the slope, that is he. X is the variable that is on the x-axis. So y, and this is on the x-axis. This is the slope. That's why slope is calculated by tan theta. This is written as h by E. And this is y-intercept. Y-intercept is minus 5 naught by E. So since this is minus coming, so that's why this is drawn on this axis. This is minus phi naught by E. All right, that's why it is cutting it. Intersecting it at it. So this is the straight line graph, and this is how this is calculated. Main thing you have to remember is that slope is given by h by E, that is tan theta, and the y-intercept is minus phi naught by. And this is how you have to draw the graph, and you have to show these calculations. And this is how this is done. Write it down. Any doubts if you have, please let me know. not wavelength and frequency. This is stopping potential and frequency. See, kinetic energy is EV naught. V naught is the stopping potential. Done or not, just update me all those who have done. Then I'll, one more topic is the de Broglie waves that I'll. Okay, by now I think most of you have completed. Now coming to de Broglie. What are de Broglie waves? Basically, the waves that are associated with material particles. All right, the waves that are associated with material particles are called the matter waves or the de Broglie waves. We use the term matter waves also, and the term de Broglie waves is also used. So what is meant by this? Basically, what happens is that Einstein's equation, E is equal to mc square. I've mentioned this earlier. Waves associated with matter particles, as in when these electrons, they start emitting the wave behavior also. Then we call them as the de Broglie waves. All right. So let's say E is equal to hc by lambda, we know. Let's equate both of these. So this is mc square is equal to hc by lambda. C will be cancelled. So lambda is equal to h by mv. Or you know what is m into v? M into v is momentum. So this is h by p, where p is your momentum. P is, this is the Planck's constant. H is the Planck constant already. Now see what are exactly these. This I have just told you very short, in very short. Just understand what are these. So this also formula I told you. See, basically wavelength of these waves is inversely proportional to the momentum that is being produced. It's inversely proportional to the momentum. All right. If you increase, if you want to have a higher wavelength, you have to produce a lower momentum. That is either the mass or velocity, or both of them should be low. All right. Of the moving electron, we're talking about the moving electrons which are producing waves. Then if wavelength has to be, you want the wavelength to decrease. So you have to increase the momentum so that the wavelength that is being produced, this duration then reduces. If speed becomes more, no, what happens? If the speed is low, this is how the waves are constructed. So wavelength becomes longer. If speed is lesser, then this is how the waves are formed. Okay. And if we make the velocity as 0, so we know the formula lambda is equal to h by m v is 0. Lambda is equal to 1 by 0. So lambda will be equal to infinity. Then these are matter waves and these are not EM waves. Means you cannot use all the properties of EM waves which we have used, which we have studied about the gamma rays, X-rays, if you remember. We cannot use all the properties. EM waves properties we have done. There are certain properties for electromagnetic wave to be called as electromagnetic wave, right? So those properties are not fulfilled by it. So we cannot equate both of these. These are matter waves in the sense that this is valid for particles also. This is valid for particles. So basically, now what you can say, this was observed by de Broglie. Before this, everything that we were studying, entire topic that we were studying, we were considering electrons to be particles. Photoelectric theory completely justified the fact that electrons are simply particles which have a certain frequency, wavelength, velocity, potential, energy, and everything. Now, when we are talking, then de Broglie wavelength was, the concept of de Broglie wavelength was introduced. This gave the fact there were experiments done. We don't have these in our syllabus. Otherwise, very much details of de Broglie wavelength used to exist. So they are present. So de Broglie waves are, they told us that electrons are particles. Everything is correct. Photoelectric effect, all these phenomena are correct. But wave particle is also exhibited. That is this. Like this, waves will be formed in a circular fashion. These are known as matter waves, de Broglie waves. So dual nature, the entire gist of our lesson, when we are saying dual nature, one portion is about the particle nature, that is the photoelectric effect. And the other concept is about the wave nature of electron. Wave nature is also present in an electron, which talks about the de Broglie wavelengths. Write it down. Some more things we'll discuss. This also. Just one last thing. See, there's one relation between kinetic energy and momentum. Sometimes the questions are given like this. This is P square by 2m. So momentum can be written as 2m kinetic energy under root. So formula for de Broglie wavelength will be h by under root 2 into mass of the electron into kinetic energy. This is the mass of electron. This we write as the mass of the electron. Just write it down. This portion also, make a note point and write it down.